Find the horizontal force, Fx, in pounds force, necessary to maintain a constant cart velocity. In this problem, a hydraulic jet sprays 68° Fahrenheit water through a pipe attached to a cart. The water is redirected 120 degrees through the pipe. The velocities of the hydraulic jet and the cart are provided, as well as the area of the nozzle, a nozzle. The problem also states there is no frictional resistance to the cart moving in the x direction. Without a horizontal force, Fx, applied to the cart will not maintain a constant velocity. From Newton's second law, we know the sum of the forces in the x direction equals the mass of the object times its acceleration in the x direction. Acceleration equals the change in velocity with respect to time. And since the problem states we're interested in maintaining a constant cart velocity, there is no change in velocity and the acceleration equals 0. Therefore, the sum of the forces acting on the cart equals 0. These forces include the force from the hydraulic jet and the resisting force, Fx. Since we'll assume Fx is in the negative x direction, we'll switch the sign of Fx in our force balance equation. This makes the horizontal force, Fx, equal to the horizontal force exerted on the cart by the hydraulic jet. The horizontal force exerted on the cart equals m dot delta Vx, where m dot represents the mass flow rate in units of mass per time, and the delta Vx represents the change in velocity of the mass flow rate in the x direction, as the flow is redirected by the cart. First, we'll calculate the mass flow rate, m dot, which equals the flow rate of the jet, Q, times the density of the fluid, rho. We can look up the density of water at 68 degrees Fahrenheit, and it turns out to be 62.32 pounds mass per feet cubed. The flow rate equals the velocity of water times the area of the nozzle. From the problem statement, we know the area of the nozzle equals 0.04 feet squared. The velocity of water equals the velocity of water seen by the cart, which is the difference between the absolute velocity of the hydraulic jet and the velocity of the cart, which equals 70 feet per second. 70 feet per second times 0.04 feet squared equals a flow rate of 2.8 cubic feet per second. 2.8 cubic feet per second times the density of 62.32 pounds mass per cubic feet equals 174.5 pounds mass per second for the mass flow rate, m dot. The change in velocity of the fluid due to the cart in the x direction can be calculated as velocity 1 in the x direction minus velocity 2 in the x direction, where velocity 2 refers to the velocity leaving the cart and velocity 1 refers to the velocity approaching the cart. From earlier, we know velocity 1 in the x direction equals the velocity of the hydraulic jet minus the velocity of the cart, which is 70 feet per second. Similarly, velocity 2 in the x direction equals the velocity of the jet minus the velocity of the cart times the cosine of angle theta. After plugging in the appropriate variables, v2x equals negative 35 feet per second. This makes delta V in the x direction equal to 105 feet per second. And 105 feet per second times 174.5 pounds mass per second equals the force imposed on the cart by the hydraulic jet, which is 18,323 pounds mass feet per second squared. After converting this force to units of pounds force, the force of the hydraulic jet equals 569 pounds force, which means Fx equals 569 pounds force. When reviewing the possible solutions, the answer is C.